Sauce here. This is a video lesson on parent logarithm. We can write the equation y is equal to log of x. This is the most simplest logarithmic equation, so we call it the parent equation. We can also call this common log, not the equation, but the log base that isn't written here because it's 10. And when we have a log base of 10, we could show it, but we don't have to. If you don't see it, it's implied that it is 10. Let's make a t-table where we choose values of x and use the equation to find y. If I choose the value 1 for x, then I calculate y with this equation. Y is equal to the log of x, log base 10 of x. And it might help to remind us that we can change this into exponential form by taking the power base 10 of both sides. When we do, power base 10 of y means that we write a power where the base is 10 and now y is in the exponent position. On the right side of this equation, a power base 10 will cancel out the common log, the log base 10, leaving x. So in this case, if x is 1, we can think what power of 10 will equal 1? And we know that y must equal 0 because anything to the 0 power is 1. So in the original equation, 0 is equal to the log of 1. What if we put 10 into this equation? We get y is equal to log of 10. And remember, this is log base 10 of 10. And what we mean by that is we're looking for the power of 10 that will equal 10. And hopefully it's obvious that y must equal 1. So when we put in 10 to the parent log equation, we get 1. We have a couple of points here. We can start investigating the graph of our parent log function. If I put 1 in for x, then I will get 0 for y. Parent log has an x-intercept at 1, 0. If I put 10 in for x, then y is equal to 1. So the growth between these 2 points is a curve that grows very, very slowly. And it continues to grow very slowly. This log equation is always increasing. And it doesn't look that way. In this graph, it looks like the line is leveling off and becoming horizontal. But it doesn't. It always increases, even though its rate of increase slows down. And the further you go on the x-axis, the slower the y will increase. But it has no horizontal asymptote. It looks like it does. Logarithmic equations graph looks like it levels off and becomes horizontal or approaches a horizontal asymptote, but a logarithmic equation does not have a horizontal asymptote. It just grows very slowly. Back to the t-table, if we put something in between 1 and 10, like 3, finding the log base 10 of 3 as a value is going to be challenging. On the graph, it would be like looking for the point where x is equal to 3 and wondering, what's the y value there? Well, it's going to be between 0 and 1, and it's going to be irrational. It's going to have a decimal. It's going to go on and on and on. In other words, what we're looking for is the log base 10 of 3. We could use a calculator for this. Calculators have log keys to help calculate logarithms. The log key is on a calculator is often base 10, and calculators often only have a base 10 log key. So I could find on a typical calculator the log of 3 by pressing the 3 key and then typically a log key, which doesn't have a base written on it most often, so it's log base 10 because you don't see it. You don't often have to hit equals, but in this case, log base 10 of 3 is approximately 4.477121225, and this is irrational, it keeps going. So a decent approximation for the log of 3 to the nearest thousandth is 0.477. And we could see on our graph here, the sketch, that we've sketched it approximately correctly, between 0 and 1. Okay, how about going in the reverse direction? How about considering a value of x to be 0? Well, if we were trying to find y, then we're asking what is log base 10 of 0? Or, in exponential form, we're thinking, what do we have to raise 10 to in order to get 0? If we think about it a moment, there is no y that can be the power of 10 that will be 0. 10 can't be raised to any power to get 0 or any negative number. On the graph, the curve of logarithm approaches the y-axis. The y-axis, the graph of logarithm, is a vertical asymptote. That means that if we were to look at where the graph, when we put in x is equal to 0, has a value, it doesn't. The graph constantly approaches the y-axis but never gets to it or intersects. So there is no log of 0, and we would say it's undefined. UND is an abbreviation for undefined. We can see from the graph that we can't put any negative number in for x. There are no y values associated with any value of x that is negative or 0. So if we put anything negative like -1, it's also undefined, UND. And in general, we could say that the domain of log is anything that is positive or greater than 0. And the range of log base 10 of x is anything. As a double inequality, we could get as a y value anything between -infinity and infinity, all real numbers. The vertical asymptote is the equation x is equal to 0, which is the y-axis.